In 5.4, we just have one new thing to discuss here, and that's in terms of the sampling distribution. Whenever we're dealing with a sampling distribution, we're going through and finding an average of a bunch of different samples over the entire population. So here in this case, for this example, it says that, let us say that the average students spend on their first, I guess I forgot to put in there, this is talk about cars. In terms of the first amount that they spend on a car is $2,500. You randomly select 16 of those students. So that's one of the samples. And then you're collecting average amongst those and doing that for groups of 16 out of all of these students here. And we want to know what is the probability that the average amount spent on their cars is between $2,000 and $3,200. If we assume that the amount students spend on their first cars is normally distributed with a standard deviation of $1,200. So here, one of the key words here that also means that you're dealing with a sampling distribution here is how it's asking for the probability that the average amount spent on their cars is between $2,000 and $3,200. Whereas before, whenever we were finding probabilities at the beginning of this chapter, we were finding them for a specific value. Now we're finding a probability over an average instead. So that means we're dealing with a sampling distribution. And if you remember from looking in the book, whenever you're dealing with a probability distribution or a sampling distribution of a probability here, the mean here is going to stay the same. So the mean here that we had over the entire population here is $2,500. So that'll stay the same. And then instead of using standard deviation here, whenever we're dealing with a sampling distribution, since we want the probability over the average instead of over one specific value, we use what's called the standard error, which we can find using our standard deviation and the sample size here. The sample size for each of these samples that we're collecting these averages over. Standard error, or sometimes in the book they have it written as SE for standard error, is another way you might see it, or they might have it with a subscript E instead for standard error. And to find that, you do the standard deviation divided by the square root of n. And standard deviation divided by square root of n. Remember, n is your sample size. Anytime you see n as a symbol, that means your sample size, or what the size is of each of these samples that's being collected. So in this case, that sample size here is 16. The standard deviation in this case, so this was your n. Your standard deviation in this case was 1,200. So for your standard error here, we'd have to do the 1,200 divided by square root of 16, which is 4. So for the standard error here, if we do our 1,200 and we divide that by 4, we get 300 there for the standard error. So then whenever we're finding our z-score, which remember is how we go through and find our probabilities here, we're going to want to use that standard error value instead of the standard deviation. So once again, that standard deviation is used to find the standard error, but in terms of actually finding our z-scores, we use the standard error whenever we're dealing with a sampling distribution. Whenever it says that we need to find the probability of the average amount of something. So instead of finding the probability of one specific amount, you're finding the probability over an average from several different samples here is really what's going on for these sampling distributions, as they also describe at the beginning of section 5.4 in your book there. So here, for one of these, we'll do the 2,000 minus the overall average for the population here over that standard error. Use that in the denominator there instead of the standard deviation, since we're over a sampling distribution. Similarly here for the other one, we have the 3,200 minus the overall average, or the mean, over the standard error. Once again, whenever you're writing these out, we want to go out 2 decimal places for the z-score, since that's all the further we can go out whenever we're looking it up in the table anyway. So here for this one, we get 1.67 for the first one there. And keep in mind here that this one, since the value was less than the mean there, should be negative. You'll want to make sure that whenever you're doing these, that you're also double checking. Make sure, see if you're getting the same answers there. And then you want to go through the same sort of thing for the other one there. So there we'd have the 3,200 minus the 2,500. Make sure that you're putting that into your calculator first and then dividing it by the 300. Otherwise, if you're trying to plug it in all at once and you don't put parentheses around the numerator here, you're going to get a different answer. Your calculator will do this division part before the subtraction if you're not careful how you're entering those in. So make sure that you are being careful there. So here then, once again, we want to then go through and look up those z-score values, see what we get for those probabilities here. So here, if we look up the 2.33, that'll be on the positive side of your probability distribution chart, or your standard normal distribution chart in the back of your book there. Once again, to look that up, you're looking up the 2.3 on the left side, and then you have to go over until you get to 0.03 for that column, where those intersect is your value. So for that one there, you should get 0.9901 for the area corresponding to a z-score of 2.33. Always remember to do the bigger one minus the smaller one, because your areas and your probabilities should be positive. For the other one there, we want to go down to negative 1.6. And then we have to go over to 0.07 in the column. See where those intersect. In this case here, we get 0.0475. And once again, since we're looking at between those two values, that means that we want to go through and subtract those, because otherwise, if you don't subtract those, you're just finding the area below those and not between those values. And then there'd be some overlap there as well. So here, if we do that, we get 0.9426 for that one there. You could also, if it helps whenever you're thinking of these, since you're finding the area between those, you can also think of it visually. You could sketch out a normal distribution curve, like we've done before. If you have a negative 1.67, you have your 2.33, and you're finding that area in between there. That's really what's being represented by that 0.9426 there. So in other words, we'd expect that there'd be about a 94%, just a little bit above 94% chance there that somebody would spend between $2,000 and $3,200 on their car on average for those 16 students. So in other words, the average of those 16 students spent $2,000 to $3,200 would be 94% approximately using that information there. So remember, once again, if you're dealing with finding a probability over an average, that you're using this standard error value, using that sampling distribution instead.